code. Okay. And then share screen. Okay, so I think today we should be able to finish this unit. So last class, we started discussing this example. So this unit is about model evaluation and hyperparameter tuning. Okay, and hyperparameter, be careful, okay. We also discussed last class, for parameter, there are two kinds of parameter in machine learning. So far we have learned, is it? One is kind of like the weights, is it? We adjust weights, is it, in a number of algorithms that we learned. So the goal is to find the optimal weights. So weights is one kind of parameter. Is it? There are other kinds of parameter. You remember, like for regularization, is it? Like the C, is it? Or like for decision tree, the depth. This is the level of tree, is it? So those are the parameters that we can use to adjust the underfitting or overfitting. So those parameters we call them hyperparameter. Okay, so hyperparameter tuning is regarding those parameters. Okay, so that's just a review, quick review. Okay, then next, let's see over here. Oh, so that's what today we will discuss, is it? So in the past, what we discuss is like for parameter C, is it? The way to try it, so each time, if you do logistic regression, then you plug in with different C value, is it? And then you measure your model's performance, is its accuracy. Okay, let's see. Regarding the model's performance, so our learning model's performance. Who remembers so far we learned what kind of metrics? Metrics. Yeah, what kind of metrics that we can use to measure a model's performance? So for sure we know accuracy, is it? Anything else who remember?
Training samples?
No, performance. Performance is like your model's accuracy is the performance, like 95% accuracy. You see those kind of. Anything else who remember? You remember we said there are some matrix. Who still remember? What's that matrix called?
Confusion.
Yeah, very good. Confusion matrix, is it? Confusion matrix, is it? So related with confusion matrix are what? We call it TP. What is TP? MP? What P mean? TN, NN. You remember confusion matrix composed is made up of those, is it? So that's because we cannot just use accuracy, this single matrix to measure the model's performance, is it? And we also use the confusion matrix. Is it? So this is also related with also yesterday was some of the topics that we discussed. So who remember what TP represent, NP represent?
True positives.
Yeah, true positive. Is it? And N means what? Oh, not NP, I'm sorry, FP, I think, yeah. FN. True positive, false.
False positive.
Yeah, false positive. Okay, I'm sorry, I made a mistake. And so this N means negative. So that's regarding confusion matrix. And then related with confusion matrix, we learned we have precision, is it? And recall, is it? And F1 score, is it? So you can send your answer, okay? So who already just sent the answer, you can send your answer to the chat. So I will put down the bonus point, okay? So those is another, this is another matrix, is it? We can use to measure models performance. Keep all of those in mind also, okay? We learn machine learning, okay? So it's not just the model we keep in mind. Is it like a perceptron, add-line, linear regression, logistic regression, support vector machine? Is it decision tree, random forest? Is it? And so and some more, is it what we learned? Gradient descent, is it of those? PCA, LDA, so all of those, and we should also keep this in mind, because when you train model, your purpose is to find the high performance. Is it? How do we achieve high performance? Is it? So we need to something to measure them. Is it? So some matrix, is it? So accuracy is one, is it? And the other aspect is you can use confusion matrix, true positive, false positive, is it? Precision, is it? Recall, F1 score, to also measure the performance so that we can understand, is it underfit or overfit? Is it? Of these concepts, and also keep that also in mind, okay? That's also very important concept for us to understand your model's performance, is variance versus bias, is it? And who still remember variance, generally speaking, if it's high variance, that means it's lead to model to what? High variance, low bias. Who remember? Variance means, yeah, please.
Underfitting?
The high variance is low bias. Low bias, high variance. That can lead to overfitting, okay? Remember, overfitting, okay? Overfitting, generally speaking, is caused by what? Your model. So let's make a selection choice, okay? Multiple choice. A, Your model is too simple. B, your model may be too complicated.
Too simple.
Overfitting. Overfitting is regarding which one? If I do the multiple choice, A and B, that means your model is what?
Too complicated.
Yeah, too complicated. Okay. Yeah, so for you too, you can also send the correct answer to chat so that I can keep track of the bonus point. Okay, it's too complicated. Is it? Just think about you have the sample. Is it? Then you try to come up with some polynomial regression, is it, to fit it perfectly? Is it? But maybe the new samples that you collect maybe fall in this kind of new pattern. Is it? Then you see your model will be off too much. Is it? So if you pick a linear expression, linear regression, that fit better. Is it? Compare with your previously too complicated model. Is it? This fits better, even though there are still some offs. Is it? But overall, the error rate will be lower, is it? So that can cause, so just remember, if your model is too complicated, is it? Then it can lead overfitting. Overfitting is because of high variance, okay? High variance means what? Means your data spread out too much, okay? Spread out too much. And it's spread out too much. That's, you remember why we do PCA. Is it? PCA's goal is to what? To find the component that will align with the most spread out axis. Is it? Yeah, so anyway, so all of this are just some concept, okay? So let's keep all of them in mind. Okay, so how do we achieve, how do we tuning the hyperparameter? As so in sklearn, we have an approach to provide called grade search. So keep this also in mind, grade search. Okay, it belongs to model selection. Okay, you import grade search. Okay, then let's see. So the first one we are going to do, we need to make our model. So over here, we do pipeline. You still remember, do the pipeline. Pipeline is what we are going to streamline processing, is it? Processing, is it streamline what? Streamline data pre-processing. Data pre-processing, it's like you deal with missing data, is it? Generally speaking, what other tasks also belong to data pre-processing? Who remembers that? Who remembers besides missing data? Just think about when you collect data, is it, will all of the data be numeric data?
Is it the
Data
string
clean.
type?
Yeah,
Like labeling?
yeah. Yeah, very good. You can send your answer, okay, to the chat. So it's, we a lot of time also need to conversion data. Is it data conversion? Is it to convert data from string type, is it to numeric, is it? And there are two approaches under it, is it? You remember label encoder. Is it label encoder? Otherwise, if you don't do label encoder, you need to use dictionary, is it? Oh, the other one is one hot encoder. That is for, this deals with ordinal. Label encoder, generally speaking, can be used to deal with ordinal categorical data, is it? This is used for nominal. And both used for categorical data. So for categorical data, is that you need to convert, is it? So that also belongs to for some reason, belongs to data pre-processing, is it? And generally speaking, so this is streamline first step. The second step is to do what? Generally speaking, is feature what?
Feature selection.
Feature extraction.
Yeah, very good. Feature selection. Yeah, you can send the answer. Okay, feature selection or extraction, is it? Extraction. That's the second step. And then the third step is we pick the training model. Training model. That's what we did pipeline. So that's over here. You did pipeline, the first step. You do standard scalar. Okay, let's recall again. Standard scalar belongs to first step or second step? Belongs to data pre-processing or belongs to feature selection?
First step, is it?
Yeah, first step. What's its goal? Who still remember?
Scaling.
Is it to trim down the size of the data?
Yeah, very good. Very good. You can send your answer. Okay, scaling data. Is it bring all of your data to the same scale? Is it to the same scale? Okay, then the question is, do we need to do data standardization, data scaling for decision tree? Do we need that? For decision tree, generally speaking, do we need to do data scaling?
No, we don't need it.
Yeah, generally speaking, it's no. Is it? Okay, but here we do data scaling and we didn't do feature selection for this case. Okay, then we directly move to SVC. What is SVC model? The name. The SVC is for support vector machine, is it? Yeah. Okay, so we apply data scaling first, then we apply data training with support vector machine, is it? And if you recall, for support vector machine, we can apply regularization, is it? On support vector machine, is it? So that's regarding parameter C, is it? So that's why over here, we also have our parameter range. So it's a list, is it? So it's from 0.001 all the way to 1,000. That's the C's data range. Okay, and for support vector machine, in sklearn, we all have another parameter we need to adjust, is that gamma parameter. So that's also hyperparameter. Okay, hyperparameter. So let's see, for this grade search, therefore this grade search, if you take a close look, so it lists what parameter I'm going to use, is it for what kind of model, is it? Okay, it says for support vector machine, the kernel, if the kernel is linear. So as for support vector machine, you remember we have linear one. And to deal with non-linear, we apply the kernel method, kernel concept. Is it? The kernel concept, so in this case, okay, kernel is linear. So basically it's a linear support vector machine, is it? And its regularization parameter range is going to go from this list. This is the first approach. For the second training model, so its parameter range is going to be from this list, is it from this list? And the kernel, we are going to use RBF. Okay, so we have two models basically, is it two support vector machine models. One is linear, is it linear one? The second one is a linear, is it we apply the Gauss, the RBF, is it non-linear kernel? Okay, after that, so this is your parameter, we call it a parameter grade for this variable, is it? And then you can apply grade search. Is it grade search, then you specify the estimator. So this estimator over here, we use pipeline one, is it? And then we provide our parameter grade, is it? The parameter grade, okay, it's the list of the parameter C, is it a parameter C? And what we are going to measure, we are going to use accuracy. And over here, who remembers what a CV represents? CV represents what? Who still remember? Generally speaking, we do training and testing split. Is it? But if we just do training and testing split, sometimes it won't work well for our model, is it? So in order to pick the best parameters, is it? We add another one, V. What V represent? Here C represent. What is this? Cross.
Validation.
Yeah, very good. Cross validation. Okay. Then we have what? Validation is you go ahead, split the data. Is it in the training data set? You remember? That's your training data set. Training data set, is it? And then you further divide it into, we call it K folds. Is it? In this case, we have 10 folds. Generally speaking, we pick 10, is it? 10 folds. And then you have 10 iterations. Is it 10 iterations? And you use one of the fold. Each iteration, you use one of the fold serves as what? Validation. Is it? That's called cross, K-folds cross validation, is it? Okay, so here they just say, okay, we are going to do grade search with cross validation, okay? So basically, it looks like when we consider a lot of factors, is it, in this grade search one? But of course, we didn't consider dimensionality reduction as a PCA. We didn't apply it. Okay, so, and then you can fit your model. Is it? That's what over here we did. With the grade search, you fit the model. Is it? Then you see, the grade search, will find the best score and the best parameter. Okay, so that you don't need to manually for each of it that you call SVC. You call 10, 1, 2, 3, 4, 5, 6, 7, 8. You call 8 times of the SVC. So instead of you call 8 times of SVC, each time with a different C value, is it? What over here we just call the grade search once, is it? Then it will find the best C value, is it? And the best gamma value and the best model, is it? So in this two model here, it says this is model one. Model one, is it? And this is model two. Is it? You do the training and the best parameter tells you you need to go to this second model. And then you don't need the first model, is it? So that's the goal. And the accuracy it can achieve 98%, is it? So this just tells us, okay, with grade search, you can see it's quite helpful, is it? You just call grade search once, is it? Then it will find the best thing for you, is it? And then over here, then you can do the grade search, is it? Grade search with the best estimator, is it? And then you can next go ahead to train the model, is it? And do the prediction, is it? So that's what we call grade search. Okay, and what the next one try to tell us is we will go further, is it? We do algorithm selection with nested cross validation, is it? Nested cross validation. Okay, so what this means that, okay, first we do grade search, is it? With our estimator, the parameter list, and specify the cross validation fold is 2, is it? So over here, the K fold, K is 2. Okay, so that's 1 with our grade search cross validation. And then next we do cross validation score, is it? And over here we further plug in cross validation. And this time for our cross validation fold, K, we pick 5. Okay, we pick 5. So the idea is you have an outer one. So this is the outer iteration. Is it? You do 5 times. You have 5 times. Is it? That's regarding this one. Is it? And you have 5 folds. So this is regarding your training data. Training data, is it? You have 5 folds. Okay, so that's regarding this one. And within each of this, within each of it, I'm further going to do grade search. And I just divide by 2, is it? So training and validation, is it? And over here, I'm going to do grade search. So I'm going to use grade search for 2 folds to pick out the best parameter, hyperparameter. Is it? Hyperparameter and the model with the grade search, is it? I can find the best suitable hyperparameter and the model. And after that, I'm going to do 5 folds of cross-validation again. Is it? This is to make sure, is it, the data evenly distributed, is it, for training and validation, is it? So that can improve your final model's performance, okay? So this is called nested cross-validation, okay? Okay, then next, let's see. Next one is regarding, we can also use decision tree, is it? So here we do grade search, and we use decision tree for the estimator. And the parameter for decision tree, then it's not a regularization parameter, is it? So here you say, oh, it's the depth of the tree, is it? So 1, 2, 3, so you can specify the depth of the tree, is it? And then you do cross-validation, is it, for grade search. And then you do nested cross-validation, is it? Nested cross-validation, and then you can find the result, is it? So the accuracy is around 93-ish, is it? With this model, if you do decision tree, okay? So overall, so here it shows we can do further performance evaluation, okay? And what next shows is confusion matrix, is it? We already know, is it? And the true false, so we are not going to repeat it, okay? And the recall F1 score, precision score, is it, of those, and we learned, is it? And what over here, it further shows we can do grade search, is it? And oh, over here it also shows, with the grade search, is it? And how do we collect the confusion tree, precision score, recall, is it? So in sklearn, the matrix, is it? You can also import the model called make score, okay, make score. And then you specify what score you want to use. Over here says, okay, I'm going to collect F1 score. Is it? This is the parameter C regularization. Is it? Okay, then you said, okay, I'm going to apply support vector machine. Is it? With this range of C parameter and the different models. Is it linear model or kernel? Non-linear. Is it? So which one I'm going to use is I'm going to test in both model. Is it? Okay, then for grade search, for the estimator, I'm use that pipeline. Is it? And the parameter list, I'm going to use this parameter list. Is it? Okay, here is the score. Is it? We can use accuracy. Is it? But you can also collect the F1 score or precision or recall as a confusion matrix. So here it just shows us how do you integrate. Is it? Integrate various performance matrix not matrix. Performance matrix, is it, into grade search. Grade search, is it? You can specify specifically, is it specifically? Okay, then you can do your training, is it? Then you can collect the best score. Is it? Here it shows the best score. So this best score is what? Is F1 score. It's not accuracy, okay? So be careful. So you can specify, okay? So we can see grade search is very helpful, is it? And how do we, if you recall yesterday, is it? We also discussed of ROC, is it curve? Is it ROC curve and AUC is the area under the curve, is it? And this is to measure. You remember the this is to measure the false positive and true positive distribution, is it? You remember? So here is 1, is it? And here is 1, is it? And from 0, is it? And the best scenario will be like this kind of distribution, is it? This kind of distribution, is it? The true positive is always going to be 1, is it? So 100%, no matter how false positive is going to change, is it? And you also remember this is for random guessing. Is it random? And at least your model should fall within this area, is it? Because if it's go under this diagonal random guessing, it's too bad. It's even worse than random guessing your model, is it? So that's not good. So the best one will be this case, is it? But that's extremely hard to achieve that, is it? So generally speaking, if your model can go to this area, is it? Is it achieve something like this? It's pretty good, is it? And AOC means all of the area. Yeah, of the area under this ROC curve, is it? So this is the idea about ROC and AUC, okay? And how do we collect data to draw those? Is it here? It shows, oh, we are going to do pipeline, is it? So it's going to do data scaling. So this we do data scaling here. And here we apply PCA, is it? PCA is for what? Is for feature extraction. Selection, extraction, as here it's for extraction. And then we do model training, is it? So here is for the model. And this penalty is L2, is it? And what is the other regularization penalty? Who remember? L is for regularization, is it? And the penalty is for penalize what? Who remember? So penalize what? Penalize what in our learning model? In learning model. In learning model, we can apply regularization. Is it? You apply regularization, the goal, the purpose of penalization is what? What's the purpose? Is to penalize who in our training model, in learning model? Who still remember? Okay, so then let's go. This is beginning when we discuss, is it? If you still recall, is it like perceptron? Is it perceptron, Adeline? We learned SVM, logistic regression, linear regression, all those models when we learn, what do they try to achieve? They have what? They have that, what is this? W is what? Who still remember?
Weight.
Yeah, it's for weights. Is it? Yeah, it's to find the optimal weight. Is it optimal weight? So weight over here for regularization, is it? It's try to penalize weights. Okay, so penalize what? Penalize weights. Okay, keep this in mind. Okay, that's also very important. Okay, the basic thing, because just think about when you go to a job interview, you say, oh, I learned machine learning, is it? Then they will ask, okay, regarding regularization, it's to do penalize. What is to penalize? We should know this. Okay. Okay, so anyway, so that's regarding, we have our model pipeline, is it? And then over here, anyway, we are going to do cross validation, is it? So we specify the fault. Okay, specify the fault. Okay, that's regarding over here. And then over here, we do the pipeline, is it? And we specify also the C value with our logistic regression, is it? And the same thing, we do the cross validations faults split, is it? And then did you see over here? Okay, over here, then you fit your model. They fit the model. Okay, with regarding our splitted data. So this is splitted data. This is split. And then you just call ROC curve. Did you see? You call the ROC curve. Then you can collect true positive rate, false positive rate. Did you see? You can directly collect those two values, is it? And with those true positive and false positive values, is it? Then you can what? You can plot it, is it? You can plot, so this is true positive, is it? And here is a false positive, is it? You can plot this curve, and this is the best perfect one, is it? Perfect. Perfect is always one, the true positive. Is it? No matter how false positive will fall, is it always true positive, always one? Is it? So the area AUC is also one. Is it? All of the others are less than one. Is it? And this is the diagonal, like I said. Your model should be above it, is it? So something like this, that will be much better, is it? Because this is purely just guessing, random guessing, is it? Under this curve, is it? It's all random guessing, is it? Worse than random guessing, okay? Okay, so that's all of today's material, okay?